Okay, so this is your basic series parallel circuit. And I have over here your values for each resistor. What we're going to do is we're going to work through this circuit together and break things down and expand things out. One thing that we start with is the things that we know. Once again, that I'll just refer you to the left-hand side there. We know that R1 is going to have 10 ohms, R2 is 5 ohms, R3 is 6 ohms, and R4 is 12 ohms. We don't know our source voltage. That's something that we're going to have to find, and we're basically going to solve for all values. That's what we need to do for this circuit. So we need to know our voltage of R1, our voltage of R2, voltage of R3. We don't have any of those, as well as our voltage total. We need to figure out what our current going through each of these resistors are. R2, I have R3, and I have R4. So where do we start? Well, we know that we've got 24 volts going across this resistor. If we have 24 volts going across this resistor, we know that we can find the current, okay? So if we go I, current, of R4 is equal to the volt drop of R4 divided by the resistance of R4, we then get 24 volts divided by 12 ohms. That gives us a current of 2 amps. Okay, so we have 2 amps that is flowing through here. All right. Well, if we have our voltage that is essentially at this point and that point of 24 volts, is that not also the same point electrically as this and there? So our point A to B is electrically the same point as C to D. Okay? What this allows us to do is we can then find the resistance going across this series circuit. Okay? If we find the resistance across this series circuit, you would go R of 2, 3 is equal to the R of 2 plus the R of 3. So 5 plus 6. That's a 5, not an 8. Okay? Which equals 11. So then we can erase this here. Whoa, get rid of that big circle. Get rid of that. And we can draw one resistor here. And we call this R23. We know we have a resistance value of 11 ohms. Okay? And by using this same formula that we use down here, we can find the current going through R23 is going to be equal to the voltage across R23 divided by R23. That would be 24 divided by 11. And 24 divided by 11 is equal to 2.18 amps. So we know that we've got 2.18 amps going through that line. Well, what we can do at this point is acknowledge the parallel rule that any current that enters a node must equal the current leaving that node, i.e. the current that is there or the current that is going down there. So our I that is of the node, we could say, is equal to the current from C to D plus the current from C to A to B to D. You can see how I'm following that around, right? Okay, so then let's get rid of that. And we'll go 2.18 plus 2 is 4.18 amps. We know that we're going to have 4.18 amps here. Okay, it's entering and then leaving, and then we'll have coming back out here another 4.18 amps. Well, if we know what the current value is here, we now know that the I of R1, because whatever current value exists here also exists there, is going to be 4.18 amps. Okay? Because we know that, now we can find the voltage. So we go voltage of R1 is equal to the current of R1 multiplied by the resistance. So 4.18 amps times 10 ohms will give us our voltage, 41.8 volts. If we want to find out the total voltage, or V total, what we are going to need to do is find out or recognize what the volt drops are in our circuit. We know that in a series circuit, voltage total is equal to voltage of one load plus the voltage of subsequent loads. But in a parallel circuit, the voltage total is equal to the voltage of 1, which is equal to the voltage of 2, right? Or each one of those lines. And we see here that we've got 24 volts on this line. So we could collapse this down one more step, get rid of that, and then we could acknowledge that we have 24 volts here and 41.8 volts here. We would then use the series circuit formula, which is what we have, and we would go 41.8, here's your series circuit formula, plus 24, and that would give us our 65.8 volts. That is our total voltage. Okay? So, we found the current that is going through I2 and 3 to be 2.18. We found the current to be going through I4, which is 2. All these values filling up. Now, we need to find the current. We'll draw this back in here. That is going through each one of those, we need to find the voltage that's going across individually these two resistors that are in series on this one branch of the circuit, being R2 and R3. The way that we would go about that is, once again, we know what the resistive value is of R2. So if I'm trying to find the voltage of R2 is going to be equal to the resistance times the current. That's better. So our resistance is 5 ohms, and our current is 2.18 amps. Once you multiply those together, you get 10.9 volts. And then across your R2. So we'll go over here and we'll go 10.9 volts. And then we do the same process for our R3. So V of R3 is equal to R3 times the current of R3. Remember, this is a series circuit right here. This little mini series circuit. So whatever current's here is also the current that is here. So then we go 6 ohms times 2.18 amps. That gives us a voltage of 13.08. To double check, you can acknowledge that your voltage of 2,3, right? Remember that combined resistor, is going to be equal to the voltage of R2 plus the voltage of R3. And if you do that math, going 10.9 plus 13.8, it will give you just under 24 volts. So we're right at the cusp. We're at 23.98 volts, which is plus or minus 1%. So we're good on our answer there. That is how you do a basic series parallel circuit.